Occasionally, cosmic events of monumental scale occur billions of kilometers away from Earth, reverberating throughout the universe. And now, a similar event is looming, sparking astonishment even among scientists. Betelgeuse, a red giant star situated at the outer reaches of our galaxy, is transmitting ominous signals across the cosmos, captured by the James Webb Space Telescope. Astronomers have uncovered deeply unsettling revelations about this colossal celestial body. As distinguished astrophysicist Brian Cox issues a grave warning, a pressing question arises. Are we teetering on the brink of witnessing a cataclysmic supernova explosion that could permanently alter the familiar night sky? Before delving into further details, make sure to subscribe to our channel if you haven't already. Now the burning question lingers, will this explosion impact Earth, and will it be visible from our planet? Stay tuned as we explore the answers to these compelling questions in this video. In the vast expanse of the universe, where the drama of stellar birth, life, and death unfolds in mesmerizing splendor, one particular star has recently commanded the attention and concern of both astronomers and the general public. This star, known as Betelgeuse, stands out prominently as a red supergiant in the constellation Orion, boasting immense size and age. While its striking reddish hue and fluctuating brightness have long fascinated observers, recent events have further piqued curiosity about this celestial behemoth. As we delve into the essence of Betelgeuse, we find ourselves on the brink of a potentially monumental event in the star's life cycle. But what do these shifts in Betelgeuse's behavior signify? Could we be witnessing the beginning of an extraordinary cosmic spectacle of unimaginable magnitude? Betelgeuse, boasting a size approximately 764 times greater than our Sun, stands as a colossal giant among stars. Its sheer magnitude stretches the limits of human imagination. Picture a star so immense that if it were to take the Sun's place, its surface would extend beyond Mars' orbit, enveloping Mercury, Venus, Earth, and Mars within its stellar grasp. This extraordinary size not only highlights Betelgeuse's physical enormity, but also signifies its place in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight phase of its existence, marked by expansion and cooling. After a lifetime of fusing hydrogen into helium at its core, questions arise about Betelgeuse's age. Despite being relatively young in human terms, estimated at around 8.8 to 8.5 million years old, it stands as ancient within the context of stellar lifespans. Its current state as a red supergiant represents the culmination of millions of years of stellar evolution, characterized by profound transformations from a hot blue star to the majestic red giant we observe today. The journey of stars like Betelgeuse unfolds as a tale of constant change, fueled by the unyielding forces of nuclear fusion and gravity. One notable feature of Betelgeuse's current phase is its striking reddish hue. This crimson color arises from its comparatively cooler surface temperature, a contrast to stars like our Sun. While our Sun blazes at around 5,500 Kelvin, Betelgeuse's surface is cooler, clocking in at about 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light with wavelengths that paint it in shades of red. However, this hue isn't merely an aesthetic trait. It offers insights into the star's physical state and the ongoing processes within its expansive gaseous realm. Adding to the intrigue surrounding Betelgeuse is its intriguing color history. Ancient writings from Roman and Chinese sources suggest that some 2,000 years ago, Betelgeuse appeared yellow. It wasn't until the 9th century that Arabic scholars described it as red. This historical shift in color isn't just a footnote in astronomical records. It serves as a clue to the star's evolutionary journey. The fluctuating brightness of Betelgeuse adds another layer of fascination. It behaves as a semi-regular variable star, meaning its luminosity goes through periodic fluctuations. This dance of brightness has captivated astronomers and sky watchers for ages. Typically, Betelgeuse follows a 400-day cycle, alongside a longer 5-year cycle, documented as far back as 1836 by Sir John Herschel, and possibly even earlier in Aboriginal oral traditions. Yet, what truly sets Betelgeuse apart is not just its varying brightness, but its irregularity. Unlike many stars that adhere to predictable patterns, Betelgeuse occasionally veers off course from its expected dimming and brightening rhythm. This irregularity hints at complex and less understood processes unfolding within its massive structure. Recent groundbreaking discoveries captivated astronomers and skywatchers worldwide when Betelgeuse experienced an unexpected and dramatic transformation, now famously dubbed the Great Dimming. It all began in late 2019 when Betelgeuse, the red supergiant shining brightly in the night sky and a well-known part of the Orion constellation, started to undergo a mysterious dimming. The dimming was so striking that it lost luminosity at an average rate of 0.01 magnitudes per day, hitting its lowest brightness by February 2020. Betelgeuse, typically visible to the naked eye even amidst light pollution, significantly faded, a change even amateur observers couldn't miss. However, there's a significant challenge in monitoring the activities of Betelgeuse: the time paradox. When we observe a star like Betelgeuse, we're not witnessing its current state, but rather its past, owing to the time it takes for light to reach us. Betelgeuse, situated roughly 725 light-years away, means the light we see today departed from the star nearly 7 centuries ago. This time, delay complicates efforts to anticipate and track sudden changes in a star's behavior, since we're essentially observing events that occurred in the distant past. The dimming of Betelgeuse serves as a stark reminder of the inherent complexities in real-time astronomical observations and the constraints of our understanding when grappling with the immense scales of the cosmos and the time paradox they entail. The captivating saga of Betelgeuse's cosmic performance was meticulously tracked by Andrea Dupree, the Associate Director of the Center for Astrophysics at Harvard and Smithsonian, alongside her team. Employing the Hubble Space Telescope, they embarked on a 3-year investigation to monitor fluctuations in Betelgeuse's outer atmosphere. These observations provided an unparalleled understanding of how a variable star like Betelgeuse operates, with its regular expansions and contractions leading to fluctuations in brightness. The remarkable sensitivity of Hubble to ultraviolet light enabled the researchers to delve into the layers above Betelgeuse's surface, which were partially heated by the star's turbulent convection cells. Additionally, a detailed analysis of the Hubble spectra obtained at various intervals throughout 2019 and 2020 facilitated the measurement of material movement within Betelgeuse's outer atmosphere. Specifically, the analysis focused on the magnesium 2 lines within the spectra, which offer insights into the atmospheric conditions of the star. These observations unveiled material traveling at speeds of approximately 200,000 miles per hour from Betelgeuse's surface to its outer atmosphere. This heated and dense substance eventually expanded millions of miles away from Betelgeuse, serving as the precursor to the dust cloud responsible for the star's dimming. Dupree and her team estimated that during the 3-month outburst, roughly twice the usual amount of material from Betelgeuse's southern hemisphere was shed. This substantial loss of mass holds significance, particularly considering that, like all stars, Betelgeuse continuously sheds mass, albeit at a rate much higher than that of our Sun. The magnitude of this mass ejection and the resulting dimming prompted discussions among astronomers regarding whether this occurrence might foreshadow a supernova explosion. The proximity of Betelgeuse, positioned approximately 725 light-years away from Earth, adds to the fascination. If such an explosion were to happen, it would be visible from Earth, presenting a rare opportunity to closely observe a supernova. However, the question persists. What implications does this dimming event hold for Betelgeuse's future? Does it signal an imminent supernova, or is it merely a distinctive chapter in the star's extensive and intricate journey? Various theories were proposed to shed light on this phenomenon. This sudden shift prompted several prevailing theories. One proposed a phase in the supernova explosion process, gaining momentum due to the widespread belief that Betelgeuse is nearing the culmination of its life cycle. Another widely accepted theory implicated dust, potentially originating from the star itself, obscuring our view. Betelgeuse, akin to other red supergiants, is recognized for shedding material, leading to speculation that this material could coalesce into a dense dust cloud, diminishing the star's luminosity from our vantage point. A third explanation scrutinized alterations in the star's photosphere, its visible surface layer, which might impact its apparent brightness. Comprehensive analysis employing diverse observational techniques contributed to unraveling this enigma. Spectroscopic examinations indicated a decline in Betelgeuse's effective temperature, hinting at the possibility of a substantial dark spot on the star's surface. This hypothesis found support in observations revealing a temperature drop of at least 170 Kelvin during the dimming period, underscoring significant surface changes. Ultimately, the key to comprehending this peculiar phenomenon stemmed from humanity's watchful eye in space, the Hubble Space Telescope. Hubble's meticulous observations unveiled that Betelgeuse's dimming likely resulted from a substantial expulsion of heated material into space. This material coalesced to form a dust cloud, obscuring a segment of the star's surface and diminishing the amount of light reaching us from Betelgeuse. The genesis of the dust cloud was attributed to superheated plasma, which erupted from a sizable convection cell on the star's surface and traversed through its scorching atmosphere to the cooler outer layers. Upon cooling, this plasma gave rise to dust particles, culminating in a cloud that obstructed light from approximately a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations, initiated in January 2019, played a pivotal role in reconstructing the timeline leading up to Betelgeuse's dimming. These observations detected indications of dense, heated material traversing through the star's atmosphere in the months leading up to the dimming event. By December 2019, various ground-based telescopes also noted the star's diminishing brightness, particularly in its southern hemisphere. Initially, this material appeared brighter than the star's usual luminosity, eventually culminating in the formation of a dark cloud as it dispersed outward and cooled. The proposition was that this outward flow of material and the subsequent dark cloud were responsible for the sudden dimming of the star. The magnitude of this ejection is truly staggering, thrusting Betelgeuse into the astronomical spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material, believed to outweigh our moon several times over, marked a significant event not only for Betelgeuse, but also for advancing our understanding of stellar mechanics. But what are the implications of such a massive ejection of material for Betelgeuse and the broader theories of supernovae? The ramifications run deep. Conventional wisdom suggests that red supergiants like Betelgeuse steadily shed mass before reaching the explosive culmination of their existence. However, the magnitude of this ejection challenges this notion, hinting at a potentially more tumultuous and unpredictable final phase for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion within the coming millennia? Recent research speculates on the timing of such an event, proposing that it might occur sooner than previously anticipated, perhaps in just a few decades. Additionally, the concept of the bow shock adds another crucial layer to the Betelgeuse conundrum. As this immense star races through space at about 67,000 miles per hour relative to its surrounding interstellar medium, it generates a bow shock, akin to the wake formed by a moving ship's bow. This phenomenon arises from the star's outer layers interacting with interstellar gases and dust, offering a spectacular demonstration of the star's dynamic behavior and its engagement with the cosmic milieu. But what about Betelgeuse's recent behavior? Its surface cooling and decreased density observed in the aftermath of the ejection event leave the star in an unsettled state even years later. Hydrodynamic simulations suggest a link between the star's convective actions, the mass ejection, and subsequent shifts in pulsation modes. This ongoing instability prompts inquiries into the internal mechanisms propelling these alterations and their potential outcomes in the future. Additionally, the observed mass loss rate of Betelgeuse exceeds that of many other stars, indicating a complex interplay of internal forces. However, with the constant energy dissipation through shock heat and mass ejection, the driven pulsation, which partly contributes to this mass loss, is regulated. Such observations underscore the dynamic and somewhat unpredictable nature of Betelgeuse's life cycle, prompting astronomers to reassess their models of stellar evolution. Nevertheless, one might ponder, is Betelgeuse teetering on the brink of a supernova explosion amid all these dramatic changes? This question weighs heavily in the astronomical community. While the timing of such an event remains uncertain, the recent unprecedented mass ejection has unmistakably shifted the discourse, suggesting a more imminent finale than previously envisioned. Theories now grapple with the ramifications of such substantial material loss and its implications for the star's stability and future. Yet as the astronomical community focuses its attention on Betelgeuse, another cosmic event emerges, captivating our interest and providing a striking point of comparison: the supernova SN 2023 ISF. This awe-inspiring event unfolded in the galaxy M101, affectionately dubbed the Pinwheel Galaxy, located just 21 million light-years away. Unveiled in May 2023, SN 2023 ISF stands apart from ordinary supernovae. It represents the closest observation of such an event in recent memory, affording a remarkable glimpse into the dramatic conclusion of a star's life. The revelation of SN 2023 ISF marked a significant milestone in astronomical discovery. Koichi Itoki, a celebrated amateur astronomer renowned for his knack for spotting supernovae, first detected this swiftly brightening spot on the outskirts of M101 using a modest 0.35 m telescope. With his announcement, the astronomical community swiftly mobilized, redirecting telescopes worldwide, from terrestrial observatories to the orbiting Hubble Space Telescope, to witness the unfolding spectacle of this nascent supernova. The ensuing competition to track SN 2023 ISF's light curve yielded crucial insights into the explosion's dynamics and the celestial environment enveloping the doomed star. In the tumultuous month following its detection, meticulous records were kept of SN 2023 ISF's behavior. The supernova swiftly ascended from relative obscurity to a dazzling peak brightness in just 5 days, before gradually dimming at a rate of 0.03 magnitudes per day. Spectral analysis unveiled a multitude of vivid emission lines, a striking testament to the tumultuous interaction between the expanding shockwave of the supernova and the enveloping gas. This event wasn't simply the end of a star's life. It was the dramatic collapse of a massive star, overwhelmed by its own gravitational force as its nuclear fuel was depleted, with the outer layers recoiling off the dense core in a breathtaking core collapse supernova. However, what adds to the intrigue of SN 2023 ISF is the formation of a dense shell of gas, which significantly interfered with the shockwave's escape from the star's core. Two potential scenarios could elucidate this dense circumstellar material. Either a robust, consistent wind had been shedding material from the star prior to the explosion, or the star underwent sporadic outbursts, ejecting material into space unpredictably. In either scenario, it's estimated that the star shed up to a solar mass of material in its final 1 to 2 years of existence, indicating a turbulent conclusion rather than a tranquil one. Pinpointing the progenitor of SN 2023 ISF has emerged as a pivotal focus of investigation. Utilizing various methodologies and datasets, researchers have homed in on a probable candidate, a red supergiant. Therefore, by delving into the intricacies of SN 2023 ISF's explosion, including the characteristics of its progenitor and the mechanisms leading to its ultimate detonation, astronomers can refine their models of stellar evolution and supernova dynamics. These insights provide direct illumination into Betelgeuse's present condition and its potential trajectory towards a supernova, offering a clearer understanding of the indicators to watch for and how to decipher the intricate behaviors of this massive red giant. However, the question remains, when will Betelgeuse undergo its supernova phase? Research conducted by Japan's Tohoku University suggests that Ju may presently be in the carbon-burning stage of its life cycle, a precursor to a star's end. Lead researcher Heiso proposes that the star's core could collapse a few decades after the depletion of carbon. Conversely, scientists from Hungary's Kai Observatory suggest Betelgeuse is still in an earlier phase of helium burning. Despite these divergent perspectives, there is a consensus that Betelgeuse is poised to become the next supernova in the Milky Way, though this cataclysmic event may not occur for another 100,000 years. Throughout history, the observation of supernovae has offered invaluable insights into the demise of stars. The earliest confirmed record of a supernova, dating back to 185 CE, described a luminous star that gradually faded from view over an 8-month period. Since then, numerous significant supernovae have been documented. For instance, SN 1604, known as Kepler's supernova, remains the brightest star ever recorded in our night sky, visible across various regions of the world. Similarly, SN 1054 led to the creation of the Crab Nebula and remained visible during daylight for an astonishing 23 days. More recently, the Milky Way witnessed SN 1987A in the Large Magellanic Cloud, detected within hours of its light reaching Earth. This event marked a milestone as the first supernova identified through neutrino emission and observable across all electromagnetic wavelengths. These observations have played a pivotal role in refining models of supernova behavior and enhancing our understanding of their significance in the formation of stars. Imagine if the night sky suddenly transformed into a dazzling spectacle of cosmic brilliance, captivating our attention with the radiant explosion of a star. Picture, just for a moment, the familiar constellation of Orion adorned with an extraordinary jewel. Betelgeuse, one of its prominent stars, now transformed into a magnificent supernova. But what impact, if any, could this breathtaking event have on Earth? Betelgeuse's forthcoming supernova is categorized as a core collapse supernova, a powerful explosion occurring when massive stars deplete their nuclear fuel and can no longer withstand their own gravitational forces. These events rank among the most energetic and cataclysmic in the universe. When Betelgeuse eventually undergoes supernova, it will unleash an extraordinary amount of energy in mere seconds, surpassing the total energy output of our Sun across billions of years. While the energy release primarily manifests as electromagnetic radiation, including visible light, X-rays, and gamma rays, the most immediate and remarkable consequence of a Betelgeuse supernova would be an awe-inspiring celestial display lighting up our night sky. Thank you for watching. If you enjoyed this video, don't forget to hit the like button and subscribe to our channel for more content like this. We value your feedback, so feel free to leave a comment below with your thoughts or suggestions for future videos.